Assalamualaikum warahmatullahi wabarakatuh. So, hello everyone. Today I want to give a bit information or tutorial how to make a motor control. Oh yeah, this is maybe just demo because wait because I don't have motorcycle and the tools, so I borrow my friend's tools and motorbike. So first, this is the code of Arduino IDE, and let me explain. First, so this code is designed for an ESP32 microcontroller to wirelessly control a vehicle ignition and starter system via classic Bluetooth. So it uses an active flow relay module, meaning the relay turns on when the signal is low and turns off when the signal is high. So first, this is the libraries include Bluetooth serial. So this imports the specific library required to use the ESP32's built-in classic Bluetooth. This Bluetooth serial BT describes an object named serial BT that we will use to send and receive Bluetooth data. And here string res temporary container string to store the incoming text comments from the smartphone. And this is the pin's definition. Starter pin 25 and kunci pin 26. So it's assigned the ESP32's GPIO pins 25 and 26 to control the starter motor relay and the ignition or key relay atau kunci relay. Starter delay, this is a safety timer. It ensures the starter motor only cranks for exactly 5 seconds or 1500 milliseconds, so the starter motor doesn't burn out. And this bold kunci on false. This is a crucial safety flag. It tracks whether the ignition is currently on or off. We set it to false off by default. And this is the setup. The setup block runs exactly once when the ESP32 is powered on. And serial begin. This starts the serial motor for debugging via a USB cable. And this boot safety mechanism. So before configuring the pins as outputs, we first write a hike stats to them using digital writer since these are active flow relays. Writing high guarantees the relay stays strictly off while the ESP32 is booting up. So this prevents the vehicle from suddenly restarting when you first plug in the battery. And this pin mode output. So it configures the designated pins to send out electrical signals. And so to begin, this turns on the Bluetooth module and broadcasts the name "U bigger." So this is the name your phone will search for when pairing. And this is the loop. The loop function runs continuously. So first it checks if any comments has sent before sent from the phone, while this loop reads incoming Bluetooth character one by one and stitches them together into our string. So if res is empty, the code simply returns and starts the loop over again, waiting for a comment. And if data is saved, it prints data masuk and comment to the serial monitor, so you can see what comment was sent. And last is the comment logic, if else. So this is the brain of the code. It looks at the comment starts res and decides what to do. Comment T test connection is simply prints connection as tells to verify the phone and ASP32 are communicating correctly. And this is for comment D, or ignition on. Turns the ignition relay on low. It ensures the starter relay stays off. Most importantly, it updates switch on true. Letting the system now the vehicle's electrical system is now active. And this is comment 4. So this is for ignition off. So it turns both the starter and ignition relays off. It updates switch on's false. And comment A. So this is trigger starter. This contains a very important safety check. So if kunci on true, the starter relay on low. Waits for 1-5 seconds and delay, and then automatically turns the starter relay off high. This mimics pressing and releasing a push to start button. And if the ignition is off, it rejects the command, preventing the starter from cranking without electrical power. And comment 9. This is all on or ignition only. So for safety, even if a user press an all on button on their app, this code ignores the starter and only turns the ignition on. This prevents the engine from cranking indefinitely. And last is comment I, so it's all off. So this is a master kill switch command that forces both the starter and ignition relays into the high or off state and resets the kunci on flag to false. And this will print comment tidak dikenal or comment unknown, and clearing the variable. At the very end of the loop, this is clears the string, so it is completely empty and ready to receive the next comment. So for the Arduino, and let's see the page for test bits. First, as usual, you can make one folder here and open with VS Codes and add one file. I named it index.html. So look, the code is many code here. So here's so this code was a web-based GPS speedometer application. So it doesn't require installing an app. It turns directly in a mobile web browser. So It used the browser's built-in geolocation API to track the user's movement and calculate car speed, total distance traveled, average speeds, and maximum speed. Okay. This is for the style for the web. There are so many style here. I use CSS internal, so I mix CSS here inside the logic. And this is for JavaScript. Let's see the GS code. So this is start GPS. So first, if the browser supports GPS, it records the start time. The start time if the trip is just beginning. So it uses navigator geolocation watch position. This is powerful browser feature that continuously listens for location updates. It passes the data to handle position and asks for high accuracy. And this is enable high accuracy too. And stop GPS. So it's calls the clear watch ID to stop tracking the user's location to save battery and updates the buttons. And rest strip wipes all the data variable back to 0 and updates the screen to show 0. And the JavaScript or handle position. This is the brain of the app. Every time the phone's GPS gets a new signal, this function runs, extracting data and speeds from the GPS signal, and calculates some phones provide spreads directly in meters per second. If so, it multiplies by 3.6 to convert it to kilometer per hour. If the phone has a profit speed, the code calculates it manually by checking the distance traveled since the last position. So it's divided by the time passed. And okay, this move is for filter noise GPS. So this is for calculating distance and filtering noise. So this if movement measure blah blah blah. So this GPS signals can jump around even when you are standing still. This line ignores tiny movements under 3 meters GPS noise and massive impossible jumps over 300 meters per tick. So it's ensuring the distance conscious ties highly accurate. And after that, updating stats, it calculates the max speed kmh using max and average speed kilometer hour. So it's total distance or elapsed time. And after the screen, finally it updates the HTML text code starts with newly calculated numbers running them using Metron to fix Metron to fix or fix or to fix for clean display. And the last one is JavaScript for calculate a distance kilometer and two radians. So this function uses the Haversine formula because the Earth is a sphere. You can calculate distance using simple flat geometry. So this complex math formula calculates the accurate shortest distance over the Earth's curved surface between two GPS coordinates. So that's maybe for the explanation for the codes. Next, we can saw the practice when the tools into the motorbike and the test bits. Actually, I borrow my friend motorbike. Okay, first click the green one, and first is charter on, and the second one is kunci on. So next move for starter off, and last is kunci off. So this is the hardware. This is restricted to the floorboard and I/O expansion cell. So SP32 microcontroller is the top board and SP32 I/O expansion cell the bottom black board with yellow pins. And the second one is ESP32. This is the brain. Last is uh, the muscle. So it's the channel relay module maybe. So it's active low. Okay, so this is 5-year relay module, I think. Okay, you can see here. So it is the cable for plug the tools and the hardware and into the motorbike. So after that, this is for the final results of the motor by control. You can saw it. You can see it. Okay, last this is for the test bed. So you can see here this is the result of the web or page of the test bed. We should to ride the motorbike and don't forget to turn on the GPS.